Awesome. Thank you guys all for being here. And a big round of applause for the volunteers and the organizers and everybody. It's been a great time. Appreciate it. So, hi everybody. Thank you so much for being here. Quick question. How many of us are interested in RAG or building RAG applications? Okay. It's like 90% of everybody. Okay. Well, so what we're talking about is working with data, right? Because data is the core component behind data pipelines, warehouses, but more recently, it's been about building applications that can use our data using LLMs, right? The question and answering over our documents, our PDFs. But right now, we're mainly focused on just text, right? On taking maybe from OCR, all that text from a PDF and chunking that. But what we're going to show you is an open source project and what we've been using recently in order to work with PDFs, work with different types of proprietary and open source file formats to get them ready for AI workflows. So that's going to be the topic of today's presentation. You're going to see some cool live demos, hopping back and forth, going from PDFs, going from websites, going from images, right? All of this content that we have, tables that we can use in RAG workflows. We're going to show how to work with these, and hopefully it's going to be a fun time. So just a quick introduction. I'm Cedric, and I work as an open source engineer and advocate here at Red Hat. I've been working on container tools for a while, if anyone knows Podman, and I have the wonderful Legare as well.
Hey guys. Hey, I'm Legare. I'm also a developer advocate at Red Hat, doing a bunch of artificial intelligence stuff with Cedric.
Yes, and all open source, which is fun. So what's funny is that, we don't really think about it, but 85% of the world's data is in unstructured formats. So think about everything other than SQL databases is data that can be hard to work with for LLMs, because LLMs work with JSON, they work with Markdown, right? All these simple text formats that are simple language, right? And if you want to take your PDFs or other file formats and get those ready for RAG workflows and applications, well, you might have to work with proprietary services or send your data to someone else. We're going to show you how to do that all completely local, so that you can parse charts, you can parse tables, go beyond just simple OCR, go to audio and photos and have all of that content ready to be taken and used in a RAG workflow. So we'll use an open source project called Dockling to do this. This is a recent project from IBM Research, but it's been quickly growing in popularity at 40,000 stars on GitHub. And I know that we're not able to use Google Slides for now, but if you want to copy this link, you could get the slides, or they're also on the website. So we'll go through a couple different demos. One of them is parsing that unstructured data from PDFs, from the tables in a PDF, the images in a PDF, all of that content, and then taking that, chunking that in a specific way to get the best results back from a Q&A app that we'll show deployed on our local machine. So over to you.
All right. Okay, guys. So why is there a need for advanced document processing? Data is obviously the key ingredient behind artificial intelligence applications. You guys have probably heard the term trash in, trash out. The quality of your model is going to be the quality of your data. And there's a lot of data, as Cedric mentioned, that is unstructured. It's not in a SQL database. It's things like technical documentation, meeting minutes, financial documents, knowledge base articles, all things that could differentiate your customized large language model from all of the other customized large language models out there that we want to be able to get into a format that artificial intelligence large language models can ingest. So once we can ingest them, then we can do things like RAG and fine tuning to then customize those LLMs like we spoke about. We can pull models from Hugging Face. We can use models like DeepSeek. We can use OpenAI's new model that they just open source. There's a bunch of different things that we can play with, work with, and make our own for whatever our use case is. And data processing and prep is quite important. Like a year ago, we came across this tweet of someone saying like this brand new term was cited in 20 plus research papers because of inaccurate data processing that couldn't tell the difference between these columns right here. So if you look here, you can see like there is a line there. And as a human, we know that this is one paragraph and then we go over and there's another paragraph. But with optical character recognition, OCR, it can't necessarily tell the structure of the articles, the data that you're putting into it. And there are different things that you can use that understand structure. But if you're just using typical OCR, it might miss this. And something like vegetative electron microscopy might be cited in 20 research papers. So a simple PDF parser, again, we just went over how that can go horribly wrong. It can be incomplete. It won't understand your structure. It can be noisy. But then the alternative is to put something into ChatGPT and have them parse out your data like that. But that's going to be hard to do at scale. That's going to be expensive. And then you're having to give your data away. It's not local anymore, right? And if we have stuff that's sensitive, we might not want to put it into the ether. So we want to introduce a project called Dockling. Cedric mentioned it briefly at the front. This is from IBM, and it's going to combine OCR and typical PDF parsing technology with optical AI, right? Models that can understand structure, can understand tables, can understand images, and extract data from there. So here it is. As I just mentioned, it can do advanced PDF understanding with page layout understanding, table structure, code, formulas, and it has a plug and play ecosystem integrations, lots of cool features. We're going to go over those, and we're going to take it all the way from unstructured data to large language model chatbot application with your new data. All right, back to Cedric.
Let's do it. And at the bottom here, we just kind of, this announcement is a few months old, but it's part of the Linux Foundation now among some other projects that were donated. So there's now a governing organization. You can trust that it's always going to be an open source project. And if you install it on the CLI, there's kind of a wrapper here. Oops, tried to do laser, but there's no laser. There's a CLI in order to just use it from a terminal. So you could do a dockling and genuinely the file of your local PDF or something that's hosted remotely and get that straight to JSON or to Markdown so you can start to see the results just like that. The demos we're going to be doing today, let's have some fun, are though going to be using the library for Python. So over here, and I've got the repo for this I can share at the end of the presentation. We've got a couple different notebooks we're going to have some fun with that are going to show some of the functionality of dockling and kind of before and after, right? So a library that's commonly used for doing, parsing from the web or from local documents is Beautiful Soup. But the thing is, it really, really depends now on how, one, the quality of the data, but also two, the amount of data we have, because with token cost rising, every token that you have is charged, right, in some sort of way on ChatGPT's API or Claude's API. So you have to be very sensitive about how much data we're chunking and how much data we're getting back from our results. And when we have reasoning models, this gets even longer. So let's go ahead and import Beautiful Soup. And we're also going to do something that is a token count. So we'll use, as an example, GPT-4 Turbo. Does anyone know Sunny Brian's? It's like a barbecue spot down the road. Okay, we still got to hit it soon. But if I kind of open this up in my browser, right, this is all information that if we wanted some Johnny Bryan's, Q&A bot on the right-hand side to be like, hey, I want catering, we could, chunk this information, embed it in a vector database and have it parsed so that we can ask questions with an LLM. Now, let's go back over here and let's go ahead and just take this source, right? And we're going to use request to get that information back. And then we're just going to parse how many tokens there are in this HTML index page, right? So you can see all this information. This is it's on some, WordPress CMS. We've got a little bit of documentation information here, right? If we're just parsing all of that raw information, can start to really build up. So even tools like Beautiful Soup have ways to do HTML parsing, right? So if we just do the HTML, the raw data from that page, we end up getting much, much less information. But the thing is, all of this isn't formatted in a way that's one, readable by humans, and two, readable by LLMs, right? We've got a little bit of information here, but nothing's really kind of formatted in the way that one would read, right? And so if we try to put this into a RAG application, we're going to get bad results back. As Legare said, garbage in, garbage out. So let's come over here. And so this is before parsing and after parsing, right? It's a basic example. And what dockling does, so I'm importing the dockling document converter, and we're going back to that same website. We're doing converter.convert and just putting that into Markdown locally here in a Jupyter notebook. We see the same website, but now it's a little bit different. So dockling is really focused on the layout of a website. So you can see that, hey, the header would be one singular, was this it's hashtag, right? Okay, sorry. And then, you have the Markdown embeds for links, right? You have all of this information that before we weren't able to get from a simple library like Beautiful Soup, right? But then let's go to PDFs. So let's go to something that's a little bit more complex. Here I have a report from a charity, right? So this is their annual report, a food bank. And a food bank like this is going to have a lot of information that would be really helpful to be able to query on, right? There's images, there's headers, there's a table of contents. And the biggest thing now that people struggle with in RAG applications is taking data from charts like this, right? If you were to do OCR, you're going to not have the layout preserved. But if we go back over here, let's try this out. So in the experimentation, we'll parse, instead of that website, we're going to do that PDF that we have locally in my test folder. You can see here that you could either use, I think this is the Mac Silicon accelerator, but you could use CPU as well to then get that information back. We see, hey, annual report. And remember that table that we had. Now the table has been, because of a vision model, been parsed. And we're going to talk about how this works here in a second, but we have all of the tables, we have all of the columns preserved. And so now if I was to take this and then use that in a RAG application, we'd get much better results back than something that would be a singular line or truncated, right? So that brings us back over to the presentation, because just like a Hollywood movie, there's a lot happening behind the scenes, right? You know, this is what we see, but what's actually happening in the background is a little bit different. The document layout is really important when you're working with PDFs, especially, right? Because PDFs, it's a easy to use file for humans, but the thing is, this is more or less a proprietary format that's not easily encodable and usable by an LLM. So behind the scenes, what's actually happening is we're uncovering the document's characters, the words, and the lines. And so before any OCR is even done, there's a few different models that will, one, pass through the tables and graphs, and two, pass through all of the different text, words, and lines. And you could use a variety of different models for this. What's cool about Dockling is it's a modular architecture. So you could say use Gemma for images. So if I have, some type of photo, I could pass that with a vision model, or we could use one of these small models. So Hugging Face actually, releases small LMs. So they perform very well and can be used just on CPU, as well as vision models. So you could use small VLM, and that's what we're using here in Dockling in order to do layout recognition. So let's go back to this document. I have personally identifiable information somewhere in this PDF. What we can do is use Dockling to uncover the layout so that when we get the results back, we can see the bounding box exactly where that information is. So we could censor that out, right? We could use this locally, but also censor out all of that information. Now, what we're also going to take a look at is chunking. So chunking is just a way of separating one big document into a database so we can retrieve that. But it always is a small context window, and every embedding model from OpenAI's to Hugging Face models are different, right? And there's a variety of different chunking strategies. So the most basic is just by token count. Hey, 500 tokens go here, 500 tokens go there, and we just parse the whole file. There's also semantic chunking. So every paragraph, I want you to break that up. Overlap chunking, so that, hey, even though we're splitting it up by paragraph, we're going to have about 10% of the upper paragraph and 10% of the lower paragraph into one chunk. Recursive chunking, which is just hierarchically, so going down the document. And then real hierarchical is by tables and by sections and columns and table of content. That's how we're breaking it up. So a lot of us might use LangChain, right? Raise your hand if you've used LangChain before in your apps. So LangChain makes it really easy from a client side to make the calls to a model and to build a RAG application. But if you're using by default the recursive character text splitter, literally what's happening in the background is we're splitting it up. Say it's a Python file by class, or maybe by headers or something in the document. And so this preserves this semantical content. But the thing is, it can get kind of messy if there's different parts of information that are related, but they aren't chunked together, because then we get bad results from our application. So if we were to actually take, say, for example, this blog and just do recursive character splitting on it, well, we would chunk, say, for example, the title and then the first sentence and the second sentence. But those two sentences are related, right? So why not keep them in the same chunk? So it's really important, if you're looking to get the best results back, to ensure that those chunks are related and that they're grouped together. If not, you're going to have two different pieces of information, and the LLM has to determine if they're related or not. And then it's kind of just a guessing game. So there could be overlaps, and that's what we talked about earlier. But it's really just something like this, right? It's separating by every time it sees class or a definition or something like that, and maybe doing a little bit of overlap. What we're going to show real quick is a hybrid way to do this chunking. So if I've already parsed that document, what I can use is something called dockling document. It's a pydantic data type to separate the different headers, the different columns, the text, the tables all together by relevance. So we would have, say, for example, chunk number 1 and chunk number 2, and all of these are similar content in the actual document, right? So we're not going randomly by, hey, this is one class and this is a second class. It's by what's related in the format of the document. So we'll actually try this out here in a second. So let's come over here, and we're going to first, actually, I should have shown this earlier, is doing multiple formats of conversion, so PDF or PowerPoint or PDF. And when we parse that with dockling, so we're setting up a converter right here, allowing for all these data types, and then printing them out locally. Well, we've got not only Markdown for this, so this is what we saw earlier, but JSON if we want to parse through there, or maybe, for example, YAML. And so this allows me to reference all of the different components, and you start building out some type of data lake or data warehouse with all of our PDFs and run it local. So let's come back over here. I want to show one more cool thing before we get to the chunking is, we have a lot of images in our PDFs or documents, right? So what we're doing here, let me actually come back over here, is we're saying, hey, to a vision language model, describe the image in 3 sentences. And so when we actually run this, and I'll just skip down in the sake of time, we can see that, hey, we've got a couple different, logos, but let's say we've got, some people in an image, and we can use annotations from a 250 million parameter model to say, what's happening in the image, and then combine that when we're actually chunking. Okay, so let's go back to that hybrid chunking. So we're over here, and we've imported dockling. We've imported that PDF as well. And we've done just the parsing, right? We're going to use a hybrid chunker to then go through, and we're going to, by about every 300 tokens, just chunk it, right? So we've got the first chunk of the annual report and what it's doing, and the second one, a message from the co-founder, and then we'll keep on going down, and all of this information is now related contextually in the document. So it's hierarchy, but it's also the layout, so it's just really cool. Okay, so one more thing is that, hey, we've seen both LangChain's approach, we've seen Dockling's approach. Let's actually see this in action. So we have another repository that we're going to show you here, but it actually shows a little bit of both at the same time. So if we go over here, we've actually set up, and we're using this with a local model, which is really cool. So we're using OLLAMA and the Llama 3.2. And we're actually going to go and show you really quickly that it's a little bit of a larger file, but that we're building a RAG pipeline. So we're saying, hey, answer the question based on the knowledge you have, the chunks, right? And then we're also setting up one for Dockling. So we're using Dockling's hybrid chunker, loading in the documents and then doing the chunking. And then we're also doing one for recursive with LangChain. So we're just going to compare them. And when we actually come out here to our application, let's go ahead and do a quick refresh. So we're using a specific new PDF, and that one is just a technical documentation about the project. So if I come over here, we can see that PDF here. Oh, here's the new PDF. Awesome. So this is just the report that kind of similar to the first example you showed, where we have 2 different paragraphs, segments, left and right, broken up. We've also got images here, and then we'll also have tables down at the bottom, right? So all relevant information and more data that we could use to power an application. Now, let's come back and let's ask a question. Maybe let's ask something about this pipeline here. So if I come over here to our application, let me make this a little bit bigger. We're using the pretty standard mini LM embedding model to take our English language into vectors or embeddings. And then we'll use a Llama 3.2 to actually be the natural language so that we have those chunks answer the question. And then let's ask, you got it. What is the Dockling pipeline or something? right? So this model wasn't trained on information about dockling, right? We're going to simply be using the data that it's going to be doing during chunking. And we're going to be comparing just this hybrid chunker and just a basic, recursive character chunker. So we've got two answers here. Pretty good. You've got two PDF pipelines. Appears to be an orchestration layer. So the way we actually get that, and let's actually go to the debugging information. Is by, is by doing those chunks, right? So the chunks here using dockling, when we actually parse that document for the layout, is in different sections, right? So 3.3 pipelines, and then it says, hey, pipelines is this, right? Page 7, ecosystem, and we've got a figure here. So it parsed that figure, right? If we're just using some type of simple chunking method, we're getting kind of a cut piece of information. So instead of having those sections, right, we're having just a kind of snippet of information with a little bit of overlap. So we've got 3.3 pipelines, but then we also have the next sentence and then it cuts off, right? Or we have the sentence before and it cuts off because it's just 10% of those tokens, right? So it's really important when you're trying to get the best results back that you have the right chunks and the right chunking method and maybe re-ranking as well to get those results back. So this is the full prompt we gave to that model. What is the dockling pipeline and that contextual information? And you can see the different chunks here and the different sections versus, hey, recursive character. If we go back over here, it's kind of just little snippets, but they're not as relevant to the initial question, but that's because the way we chunk them. So that's all to say is that, it's really important to get the best results back. Something like this is the method that you use to chunk the data and the source data itself. So that was, fun little experiment. You can kind of see this in the chunking statistics here, that all these chunks, you can see the token count for recursive or the basic method are just like 120 tokens, right? But on the left side, we're able to get a more even distribution of sizes of chunks, but also the quantity, right? So cool little experiment. If you guys would like to see this repository, we'll link to it at the end. And speaking of the end, I think we might be cutting it a little bit close. If you want to check out the slides again or connect with us, please feel free. And we'd love to answer any questions and hope you try out the project. It's at dockling.io or just dockling on GitHub. And hope you use it. It's open source. Feel free to open an issue or contribute, part of the Linux Foundation. And we'll be here in the hallway if you want to answer any questions. And yeah.
Thank y'all.
Yes. So we'll stick around. We got like a minute left. If anyone's curious on maybe how it works in the background or anything like that.
What do we have?
Yes. So that's a good question. Let's say you scan like a PDF or something like that. So that's tricky. At the end of the day, it just will use your OCR engine, so Tesseract or Easy OCR or something like that. So it won't be any different than any other method that you already using. But yeah, good question.
Yeah.
More, let's say you have columns, tables, images, more on the digital side. But it's still, if you scan a PDF and it's cursive or something, it'll just use default basically.
Yeah. The value prop here is that it understands the structure of data that's structured for humans to understand it, to go beyond OCR. What's up?
Yeah, so we were trying to train a model in the Czech language, and so it just turns out it depends on the base model you're using, in order to that'll actually understand the chunks or that data. So the example that we were doing is let me see. There's like, for example, like the Czech language had this benchmark of which language model would do the best in their language. So the top one was DeepSeek and then Llama. So it just depends on like if model understands Spanish or another language, just hit the base model. Yeah.
Yeah.
Yeah. Sorry. I think we got to run, but thank you guys. Hope I had a fun